Okay, so a couple of things that we need to go over to finish up, make sure that we've covered everything important in Objective 1. And the first thing was photoelectron spectroscopy. And this is what these will look like on the test. And they're going to ask you things like what element is it? What these are. Each peak represents an orbital. So this is your 1s orbital, your 2s orbital, your 2p orbital, your 3s orbital, and your 3p orbital. So how do you figure out which element it is? The easiest way, or the best way, is to look at the heights. What you'll notice is your 1s orbital your s orbitals can only have 2 electrons. So they have tiny peaks. Your 2p has 3 times as many electrons, so it's 3 times as high. So in this case, this is about twice as high as R2. So this probably has about 4 electrons in it. If that's 2, double that is going to be 4. And so we are at the 4p. And if we look at our periodic table, the 4p is, I'm sorry, not the 4p, it is the 3p with 4 electrons. 3p. So it looks like that is sulfur. So that is the photo electron spectroscopy of sulfur. If we look at, let's look at a couple of more. So this one, we have 1s, we have the 1s2, the 2s2, and this p. So 2p, it is smaller than this peak, so that means there's only 1 electron there. So 2p1, and that would be boron. If we look at this one, 1s2, 2s2, 2p6, 3s2, and again, this looks like it's double, so 3p4. Did we do that one? We did. So again, it looks like sulfur again. One of the other questions that I have seen on some of the tests is how many valence electrons does this have? And if you look, if you label them 1s2, 2s2, 2p6, 3s2, 3p4, then you know that everything in the s and the p of the last energy level are your valence electrons. So it has 2, 4, it has 6 valence electrons. Okay, let me know if you have any questions on reading those. The next thing, we've discussed these terms and we've discussed them in what they say. We haven't put the names to them. So you need to be able to put the names to them. So when you're writing your FRQs, you can use them to justify your answers. These are the scientific reasonings. So when we talk about Coulomb's law, they're not going to ask you to use this equation. You just need to understand to some degree the relationship. Basically, it is saying that as our atom gets bigger, the electrons that are further away don't have less, it takes less energy to remove them. That is basically all Coulomb's law is saying, is it takes less energy to remove an electron the further it gets away from the nucleus. This is radius. A Bohr model. A Bohr model is, and we drew these and I don't think we talked about what they were called. If I had hydrogen, there is 1 proton around the nucleus and then 1 electron. If I had sulfur, sulfur has 3 energy levels, and it has an atomic number of 16, so it has 16 pluses, and I am just going to do this, and it also has 16 neutrons, and then 1 has 2 E's, the next one has 8 E's, and the last one has 6 more E's. Six. And there's the Bohr model. If we went to the next one, the D's would be on there as well. The D orbitals, so the next, you could actually wind up if you were doing copper or one of those with those D orbitals, then those D electrons would go down and fit onto the third level. So your third level can have up to 18 electrons. Okay, so the names of these rules, the electron configuration rules. Aufbau principle, the lowest energy fills first. So we always fill 1s2, 2s2, 2p, 3s. So we fill lowest energy levels first. The Pauli exclusion principle says that electrons in the same orbital move in the opposite direction, and that's because they're repelling each other, so they're moving in opposite directions. And then the Hands rule says that when an electron is added to a subshell, we do the empty shells first. And I think on some of y'all's electron configuration papers that I graded and turned back into last week over the weekend, a couple of y'all had, if it was like 2p and it was 1, 2, 3, had done this instead of, this would be incorrect. Instead of doing like so, you have to fill each orbital with 1 before you add a partner. So this is the correct way to write that one. And I think that now completely takes care of everything out of Objective 1. So there'll be a next video over trying to finish up Objective 2. And then next week we will probably have a test. Our 9-week test will cover Objective 1 and Objective 2. So if you have any questions, let me know. Hopefully I will be there Thursday.